Here we're going to look to write expressions as single logarithms. In the previous video, if you go back real quick, we worked on expanding logarithmic expressions using these three properties. This time what we're going to do is we're going to take logarithms that have already been expanded, and we're going to condense them into a single logarithm. So previously we went from here and then we expanded. Now what we're going to do is we're going to have an expanded expression and we're going to bring it into a single log. So same properties as the previous video. I rewrote them here on the top right. Same properties, we're just going to go into the reverse order. So in part A, we have 4 log base 4 of m plus 3 log base 4 of n minus log base 4 of p. The first thing we're going to do is look at this third property where we have the exponents. So these coefficients, the 4 is going to get written as an exponent. So we're going to rewrite that first term, if my screen will cooperate with me, of log base 4 of m to the 4th power plus log base 4 of n to the 3rd power. And then we don't have a coefficient on that third term, so we're just going to leave that alone, log base 4 of p. So this 4 went up here, and this 3 went up here. Now, we did the powers property, so we have 3 terms. We have addition between the first 2 and subtraction between the second and third term. You basically follow your order of operations. So the first thing we would do is we combine the first and second expressions. Since they're being added, that's our first property. That means we can multiply our numbers. So we're going to rewrite this as log base 4, and it's important to note we can do this because they have the same log base. If they did not have the same log base, we would not be able to do this. So log base 4 of m to the 4th times n to the 3rd, and then we will subtract our log base 4 of p. Right? So remember that addition can be combined using multiplication of, in this case, the m and the n. Now our final step, and we get to use all 3 properties here. We're now going to use this second property where we're turning subtraction into division. In the previous problem, previous video, we went from division into subtraction. So this would become log base 4. And I'm going to use parentheses here just to keep things a little bit more organized. I'm going to say m to the 4th n cubed over p. So log base 4 of m to the 4th n cubed over p, and that's our single logarithmic expression. Your final answer, we're looking for single logarithms, so you really should only have the word log written once, which in this case we do. So that is our single logarithmic expression. In part B, same properties, we're just looking at the natural log this time. So here, low battery, here we need to use our powers property. So the exponents of 3 and 2 are going to go as, the coefficients are going to become exponents. So the natural log of 2 cubed minus the natural log of 5 squared. All right, so this 3 went here and this 2 went up here. And now we have subtraction, so we turn that into a division problem. So we take the natural log of 2 cubed, that's a mess there. So the natural log of 2 cubed over 5 squared, apologize for this. Let me give you a little extra time to catch up anyway, 5 squared. And now the same as before, we took numbers and then we wrote them as their exponent version. We're going to take the exponent version and kind of do the opposite of that. So 2 cubed, we're going to rewrite as 8. And 5 squared we would rewrite as 25. So this is very similar to the previous example, the previous video. The only thing different here is we are reversing the process. Previously, we went from a single log and we expanded it. Now we're going from expanded expressions and we're condensing them to a single log. Still have to make sure we're working with these 3 properties in that top right corner. That's it. Practice the practice problems and you should get a pretty good understanding of this.